Okay, good morning everyone. As predicted, I was up all night with my son who was sick, and now I am also sick. So because of that, we're just going to do our trig lesson like this today. So make sure you have your blue books out, and we're going to finish off most of this note. So make sure you're looking at MT2 trigonometric ratios. And we're going to kind of fill in some of the things that we didn't the first cycle. So starting at the top here, we looked at the different ratios that we were able to use when we are looking at right angle triangles. And now we're just going to give names to those ratios. So if you look at the top of your trig table, you have the three ratios. Each one has a special name. So the first column is the sine ratio, then the cos ratio, and the tan ratio. Okay, so you're welcome to write those at the top of your trig table if you want to later, but you probably don't need to. So we use this little acronym here, SOHCAHTOA, and so it just means that sine is O over H, cos is A over H, and tan is O over A. So when you write that as an actual equation for each ratio, it would look like sine of an angle, or sine theta, will be equal to the ratio of the opposite side divided by the hypotenuse. And then cos of an angle, okay, or cosine is the full name, so the cosine of an angle is the adjacent side divided by the hypotenuse, and the tan of an angle is the opposite side divided by the adjacent side. So make sure you've added that into your note. Everything up here stays the same, and then really not much changes down here. We just will no longer need to actually look up the trig table anymore. So how about we start with finding a missing side first. So in this first one, we used the opposite over hypotenuse ratio. So when you go to write that, instead of just writing O over H, you would write sine theta equals O over H. So sine theta equals O over H. And then when you fill in your angle here, make sure you put sine in front of it. So sine 35 equals the missing side divided by 4.9. Okay, so sine would go right here. And then that's all that we really have to change, because here, instead of looking this up in the trig table, looking up 35 in the trig table, you're just going to put sine 35 in your calculator, and it's going to give you that decimal there. Okay, so I'll show you. So if you have a calculator like mine where you can see what you're inputting at the top, okay, first thing you're going to do is make sure, everyone will do this, but make sure you have your calculator in degrees. So somewhere on your calculator there should be like a little D. If you see the letters grad or rad, that means you're not in degrees, which means you're not in the proper units. And if you're not in the proper units, you're going to get wonky numbers. So you have to make sure you're in degrees. And if you're not sure how to switch your calculator in degrees, look at the actual model of calculator you have and Google it. Otherwise, ask your guest teacher or ask Miss Wood when she comes in a little bit later to help you with that, because you definitely need it to be in degrees. So mine is in degrees, so I'm just going to type, so it was sine 35, so sine 35, and this would be the decimal that I found in the trig table earlier. Okay, so I just skipped that step. I don't have to look up at the trig table. And that's it. Everything else you do is the same. Okay, so that's the same for this one down here, except this time we were using the A over H ratio. So that's actually the cos ratio. Okay, so if I write cos 35, Okay, I'll type cos 35 equals, and it gives me the decimal from the trig table. Now, if you have a calculator that doesn't show you what you're inputting, you can't actually type cos 35. You have to type it backwards. You have to put the angle in first and then put the trig ratio in. So you would write 35 cos, and then it will give you your decimal. Okay, so this is why it's really, really, really important that you're practicing on the calculator that you're going to be using on a test. Because when you're on a test, I will not be teaching you how to use the calculator at that moment. Okay, so you need to be bringing your calculator to school every day. Okay, so that's how you do your missing sides. For a missing angle, we're probably going to have to write this down here because we probably didn't leave enough room. But for here, we used the O over A ratio. So that is our tan ratio. So here we're looking for a missing angle. So unlike this question over here where we filled in the angle, we can't do that yet. Okay, so we have tan of an angle is going to equal 4 divided by 3. So when we divided this side, we found this, we looked this up in the trig table. Instead, we're going to use our calculators to look up what that angle is. Okay, but this is where things are a little bit different with an angle. So I'm going to rewrite this down here so it's a little bit more clear. So tan of an angle equals 4 divided by 3. So I need to get my variable all by itself, right? Like I always do when I'm solving. So I need to take tan and move it to the other side of the equal sign. Okay, this has to go over here. Sorry if you can hear my child screaming in the background there. He wants out of his crib. Okay, so when I move tan over the equal sign, we're going to use the inverse tan ratio. So the inverse tan ratio, to know that we're using that, we use the exponent of -1 over it. And I'll show you where that button is in a second. But you're just going to multiply the decimal that you would have looked up in the trig table. Instead, you're going to just multiply by the tan ratio, inverse tan ratio, sorry, to look it up in your calculator. So, right, so I had 4 over 3 on the right side of my equal sign. Now I have tan to the -1 times 4 over 3. So when you go to put this in your calculator, if you look on top of your sine, cos, and tan buttons, you should see the inverse ratios. So sine with a -1 exponent, cos with a -1 exponent, and tan with a -1 exponent. So I have to press shift to activate all of my yellow buttons. So I would press shift tan, and it gives me the inverse tan. Okay, and then I could put 4 divided by 3 in brackets there. And if I do it all at once, then I'm not rounding and getting an inaccurate number. Okay, so I should have the angle of 53, which is exactly what we found up above. Okay, when we did it with the trig table. So if you have a calculator where you can't see the input, you're going to have to do everything the opposite. So what you're going to do is 4 divided by 3, shift tan will get you your inverse ratio. So do the fraction first, so divide your ratio first, and then press your inverse tan button. Okay, so figuring out how to get comfortable with your calculator is probably the trickiest part of this whole thing. Okay, so lots of practice today so that we get used to it. So what we're going to do is a couple practice questions. Sorry, 3 practice questions actually. And what I'm going to have you do is draw these out on your own whiteboard. Okay, so the first question that we're going to do okay, so hopefully you can see that okay. All right, so I want you to copy that down on your whiteboard, and I want you to pause the video so that you can do this, and then unpause it when you're ready to do the answers. Okay, so pause the video now. Okay, So just like when we do any trig question, we're going to start by labeling our triangle. So we have our opposite side and our adjacent side. Okay, so after I do that, I'm going to write my little SOHCAHTOA mnemonic up at the top so that it's really easy to see what sides we're working with. So I'm using the O and the A side. So I'm using my tan ratio here. So let's write out the full ratio before we fill in anything we know. So tan of an angle equals O over A. I know my angle, so I'll write 51 there. The opposite side is what I'm looking for, and adjacent side is 12. So this tan 51, I'm going to keep those things together there because if I put this in my calculator, that's what I'm going to get, that like decimal off the trig table. So keep tan and 51 together as if it's one number. Even though these are letters here, they're not variables, right? We know what the tan ratio is. X is our variable. So this is like a very specific number. So using my algebra rules, I'm going to get X all by itself again, like I always do, which means I'm going to multiply both sides by my denominator here. So I'm left with 12 times tan 51 equals X. Remember, this is going to be the decimal from your trig table. Right? You just don't need to look it up in a trig table now. And also it's going to give you a much more precise number. Okay, because if you plug that in your calculator, if you plug tan 51 in, you get a really long decimal here. Okay, so you don't want to round this decimal because then you're going to have like a less accurate answer and you may as well be using the trig table. Okay, but just so that you can follow along, I'm going to write down this decimal. You shouldn't actually write this step down. Okay, you shouldn't write this step down. You want to keep that full decimal in your calculator, but just so you see, that's the decimal from the trig table there. Came from here. Okay, so, and then you're going to multiply by 12. So times 12, and that is the answer for your missing side. So 14.8 equals X. Okay, so really not different than what we did before, just instead of taking this 51 and looking up it in a trig table, we typed tan 51 in our calculator. That's it, that's all that's different there. So let's do one more, because this is the one that people find a little bit trickier. Okay, so we're going to look for an angle this time. Okay, so we have SOHCAHTOA at the top already, so you don't need to write it, but I will let you pause this video and try this question on your whiteboard, please. Okay, so again, we're going to label the sides of our triangle, and this time we're working with O and H, so we are working with our sine ratio. I'm going to plug in everything I know. Okay, so we don't know our angle. That's what's missing here, and we're doing 4 over 6 as our opposite over hypotenuse. So again, I want to move sine away from my variable. I'm trying to get X all by itself. So X equals sine to the negative 1 times 4 over 6. So this here, if I were to plug this in my calculator, and I will just to show you, okay, but again, you don't want to be rounding, so don't actually write this step out, but you'll get this number here, and this is usually what we would go and look up in the trig table afterwards to find the angle. But the calculator is just going to do that like reverse lookup for us. Okay, so we're just going to skip that trig table step now. Okay, so if I did, so I'll show you 4 divided by 6 equals, so I want to hit shift, sine, and multiply it by this answer that I have in my calculator here. So that's what the ANS button is. So that means I'm not rounding this at all. It'll give me a much more precise answer. Okay, so 41.8 equals X. And because we're looking for an angle here, we would typically round that to the nearest